Okay, so we need to know about how the nucleus was discovered, the nucleus of an atom was discovered in Rutherford's experiment. So the exam board are pretty keen on this idea of how scientific ideas develop and how one model was useful and then it was no longer, some things contradicted it, and so you have to come up with a new model. So that's what they're interested in. Just to give it a bit of background then, so originally atoms were thought to be indivisible particles. You couldn't break them up into anything smaller, but then it was discovered that in 1897 that atoms can emit negatively charged particles called electrons. Then that was Thomson who discovered that in 1897. So, and they knew that atoms were neutral overall. So if they can chuck out negative particles, there must be positive particles in there. This came here, the development of the Plum Pudding model, which we'll talk about in a bit. That's where you have a big ball of positive charge and that can't move, and it's embedded in it are the little, like the plums, the electrons, and they can leave the atom under certain circumstances. Right, this was then replaced about 1910. It was replaced by the experiment we're going to talk about, the Rutherford experiment, where he showed that atoms have a tiny, very heavy nucleus made up of positive charge. He didn't really know about protons, but he knew that all the positive charge was concentrated in the nucleus. A few years later, in 1917, Rutherford then showed the existence of a proton. He showed that that was basically the hydrogen nucleus, the proton, and he showed that other nuclei also contained, all of the nuclei contained this small positively charged heavy particle called the proton. It wasn't until 1932 that Chadwick then proved the existence of the neutron. So when we are thinking about the Rutherford experiment, it's important to remember that they didn't really know about protons or neutrons then. They just knew positively charged particles and negatively charged particles. Well, they knew about electrons, but they didn't know about protons at that point, which is a little bit important. Okay, so let's talk about the experiment that they did, that Rutherford did then. So here's the apparatus that he used. Right, so he had, this was a vacuum in here, so you've got to suck all the air out of it, otherwise the air would mess things up. And he had a alpha particle source in a lead box there. So an alpha particle, we now know, is made up of 2 protons and 2 neutrons. In other words, it's a helium nucleus, yeah, helium nucleus, and it's very dense, heavy, and it's got a lot of positive charge. They didn't know that, but they knew it was very dense and it was very highly positively charged for its size. So then they got a piece of gold foil. So there's the gold foil there. And they fired alpha particles at the, well, they allowed the alpha particles to fly out through this hole here. Yeah, and they expected them to go through the gold foil. They could detect where the alpha particles were with this microscope here. So they looked through a microscope and it had a little zinc sulfide screen at the end. And every time an alpha particle hits that, you get a little flash of light. So they counted the little flashes of light and they moved the microscope around to different angles. And they expected to find all of the alpha particles really just to go straight through the gold and so hit there. But to their surprise, they found that some of them were deflected, and occasionally some of them were deflected by a very large amount, like almost bouncing straight back. So, and this was the experiment then that showed the existence of the nucleus. So we'll see, how did that show that? Right, so go to this diagram up here. This here is these are the gold atoms if they are plum puddings, okay? If the plum pudding model was correct. So here we have got the pink is the positive charge, and that's spread throughout the whole atom and embedded in the pink positive charge are the blue negative electrons. So that's in 1917, before the experiment, that's people thought what was going on there. Now, here's the alpha particles, these little purple things here. Now, they knew they're so heavy that when they're so heavy and such a high concentration of positive charge that the positive charge in the plum pudding would not affect them because it's too spread out. They just go straight through it. Okay, yeah, it will repel it a bit because these alpha particles are so much more concentrated. They'll just go straight through it. Also, all the alpha particles just go straight through the gold, and that's when we said, you wouldn't get any deflection of these alpha particles. They'd all just go. The angle would be no angle of deflection. Right, that's not what happened. A lot of them did get deflected. So that model of the positive charge all being spread out was obviously wrong. And Rutherford explained it like this. He said, what you've got here is you've got a load of atoms. So these are the gold atoms in the gold foil. And the electrons are just orbiting around the outside, the negative electrons. I'll draw all those in. And what you've got is a tiny positive charge. The positive charge is squashed into a tiny, tiny space in the middle of the atom. And the atom is essentially mostly, all this here is just empty space. And that would explain what happened, because most of the alpha particles did just go through, just as they would with the plum pudding. But occasionally, you see this one here, if it's heading towards the nucleus like that, that positive charge is concentrated enough to repel the alpha particle, and it's going to cause it to sort of bounce back and be deflected by quite a big angle. So Rutherford's experiment showed that some alpha particles were deflected. So that showed that the positive charge must be concentrated, must be highly concentrated, but not many were deflected. What did that show? It shows that the concentrated positive charge was tiny, was very small. And we now know that the nucleus, and you do need to know that number, the nucleus is about 1/10,000th the radius of the atom. So most of them just fly straight through, but when they're heading straight for the nucleus, that is concentrated, that positive charge is concentrated enough to make it deflect. So it's usually something like a 4-mark question. You get this, you have to compare, you have to explain this experiment, why. So you've got 4 marks, something like why this experiment showed the existence of the nucleus and disproved the plum pudding model. So when you're answering this question, you've really got to say, describe what is the plum pudding model and what is the nuclear model. So you're going to get a couple of marks for saying that. And then you're going to get the marks for saying, well, what would you expect with a plum pudding? The alpha particles to go straight through. And with the nuclear model, you'd expect a very small number of them to be deflected by large angles. So that's the kind of approach you're going to need to take. And it is important to remember, they don't talk about protons and neutrons really. Probably not going to be penalized for that, but it's not really correct to do that, because in 1917 they didn't know about protons and neutrons. They just said the nucleus was an area of very high density of positive charge and of mass, and that most of the atom was empty space.